So for now, we have like some smaller processing steps left. If you, or I hope that the alignment worked for everybody. Afterwards, yeah, we can filter some results. Should we go through every filtering step now? I guess we're a bit time limited.
No. I mean, yeah, do the filtering.
Okay. Okay, so our aligned feature list, we can, yeah, filter some features out. If we have the filtering parameters here, no, we don't. Okay. Do you remember what we did for the filtering?
What?
The row filter.
Yeah.
Yeah. Okay. So now we have an aligned feature list. In that aligned feature list, let's look at it first. We have like multiple chromatographic shapes now. So every row represents multiple features in the different raw data files, which is just like represented with the different colors on the top here. And yeah, now it's already everything averaged across the whole sample set. So now we might want to filter out some features yeah, that don't meet our criteria. And for example, that could be like, okay, every feature needs to have an isotope pattern, or we need to have at least, I don't know, 5 features in a whole row. And to be reproducible. Yeah, sorry. Sorry.
It's going to be easier, like later we use the batch mode, but I think it's good to know that there's like where the modules are.
Yeah.
Yeah.
So we have featureless methods, featureless filtering, and the featureless rows filter. Yeah. And in the featureless rows filter, we can yeah, apply like some stuff like, okay, we need to have a minimum number of features. So for example, we could set this to like 5 features for every row. We can say, okay, at least some features need to have an isotope pattern in that row. We can, again, limit our analysis to an MZ range or retention time range or so on. And so we can, or we end up with the same results for the statistical guys. We will open our batch that we did before and check what we did.
It's there.
Oh, you found it?
Yeah.
Ah, okay, you found it. Okay. So then we can yeah, limit our analysis and say, okay, we need at least 2 features after alignment. Everything that appeared in just one raw data file, we don't care about.
Because we have triplicates, right? So if you have triplicates, you can think about that maybe in at least 2 of those, you will want to have the feature detected, right? And also the samples itself, they are also kind of similar. They are from like one, you know, analysis trip to the ocean, got some water, and so it's at least the same type of sample.
Yeah, and then again, with the isotope patterns that we recognize, we can also validate those. And again, we can use some smaller tolerances here. I would go with a maximum charge of 2 because we also did that before. And yeah, then we can also estimate a carbon number and yeah, remove signals if they are evidently a 13C isotope afterwards. Yeah. We did this before, and we did that just on the features or like on the featureless level. And again, we can have like some we can have some shifts due to overlapping signals in the MZ range, and we can also yeah, have weirdly distributed isotope patterns. So it yeah, just makes sense to yeah, do like multiple feature filtering steps. Yeah.
Yeah, it's like just a different thing a bit. Like, so we had the 13C filter in the beginning. Is just to remove evident 13C features that are like smaller, right? Then we did the isotope finder, just like as being very open, searching for everything that might be an isotope pattern, maybe even some specific isotopes. But we didn't filter anything. Like the feature table stayed the same. And now this is like a filter that many people use because they like want to see like a natural 13C isotope pattern. If you don't have that because you're analyzing other samples, you shouldn't use this this filter. So it's only for people who have like natural 13C abundances and so on. But that applies for like biological samples usually. Yeah. Okay.
Okay.
It's just some internals from the filter. So it's gonna search for like the 13C isotope pattern. And this is just like how it's detecting if it's like a 13C isotope pattern and so on. It's a bit too much into detail. Why? You could also just exclude it completely. Like you can remove just anything there. This is not a very stringent filter. So it's not gonna be like deleting everything.
Yeah. And we also never want to remove any features that have an MS2 spectrum. And then again, or like here, we can just say as selected in main window as the feature list. And we just select the aligned feature list in the end, because now it's easier to just like select it.
Yeah. And
we press OK. Parameters not pressed properly. Nice.
Yeah.
The parameter, just put it to no parameters defined. What is it used for?
It's like a grouping parameter, like from ancient MZmine2, and it seems like if there's no default, it's doesn't do.
So when we apply it, we end up with a new feature list, and now we might have features detected in some samples, but not detected in other samples. And everything that was like kind of weird looking already, because we just had like detected in 2 samples, or even though we had replicates, we filtered out. So now we only have like the really like good and valid, hopefully, features left. And due to all the filtering that we did before, and because it was quite stringent, we can now do some kind of a recursive feature extraction. So we can see that, for example, here, every feature is defined with a retention time range and also, with a mass to charge range. And now we have a module called gap filling, which will take these ranges, go back into the raw data of all the files that we have processed, and check, okay, do we in this file where we don't have a feature currently have like some intensity for that mass to charge and retention time ratio? And if there is, and it meets our criteria, it will get put into this aligned feature list, so we can do like better statistical analysis afterwards. And I guess it's also a debate if it makes the statistical analysis better or not better, and what you do if you don't find anything. But for now, we go with the gap filling. So we go on feature list methods, gap filling, and peak finder. And we get this parameter dialog. And the intensity tolerance is basically how much the peak shape may differ from a perfect triangle during the retention time. So it could be that if you have a chromatogram, it doesn't look like this, but it could have like an edge here, and how much this edge like may stick out from an ideal triangle. And then again, we have an MZ tolerance. We don't want to add too much here. So it will be like quite low. And also, if we have a really complex sample, we don't want to make the retention time range too big. Again, if we find out that our retention time shift between samples is a bit bigger, then we might also need to adapt the retention time range here. But for now, we can go with the same that we did for the alignment. And we also don't want to just add 1 data point, but at least 3. Again, the debate about what is a correct peak shape. Any questions so far?
So it's like really, like many people say that's kind of artificial to fill in like the gaps now. At the same time, there's so many things that can go wrong before, like the filtering that we do is kind of stringent, and all the constraints that we set for the feature shapes. And so we can have errors during the resolving of features, and of course during the alignment if there are shifts. And so with this, I always say we just do an informed secondary feature finding in 1 step. So we fill in the gaps, and if there's intensity, And the mass spectrometer is very specific, right? Like it's if it detects intensity in this region, I want to see it in my statistical analysis. So that, yeah.
Yeah. And then watch out that we have the as selected in the main window, and we also select the newest feature list. And then we can press OK. And it will do the recursive feature extraction for all the raw data files, and we end up with a new feature list again. And afterwards, since, yeah.
And and afterwards, this is now like all the like major steps that we do during the processing. Some people might do like a little fewer steps, but overall, the MZmine offers like many different modules now that can work off the aligned feature list that we now have to either export and pipe the results into data platforms like GMPS, Series for annotation, or Metabo Analyst, or just your R pipeline that you have like locally. Or we could do some annotation in MZmine. But the most important thing for this workshop is that we want to export files now and make them available so that like all the other tools that we're going to learn in the next days can work with those. So everyone should now have a gap-filled feature list. And if you don't, there's a way easier way to actually get there. So, and I never do the like click step-by-step one, but if you now click on show feature list summary, so right click, show feature list summary on the gap-filled feature list or the step that you managed to do, you can get there. First, you can see how many rows you have, so how many aligned features, and then you can see all the steps that we did. We had this one step here in the front, but it doesn't matter that it's here. And then all the modules that we applied in the correct order and with the correct parameters. Now we can click on open in batch queue, and we can have all the parameters, all the batch steps in one list. So again, I'm just going to do it again. Right click, show feature list summary, and then open in batch. And yes, we want to overwrite the batch. And here you're going to see that all the steps are now nicely aligned in one list. I can remove the additional mass detection step by just clicking on this button here. And now we have all the steps that we need. So we can check again. I should now have like MS level 1 mass detection. For us, it was 1E5, so it actually worked. So we have all the parameters, everything set up. In the second step, we have level 2. It's okay. I'm not going to go through all the steps, but we end up with the gap-filled aligned feature list. And you can see that in the batch mode, we actually just use those created by previous step. So all the steps are just going to pipe in the results into the next step. So you don't have to select with some naming patterns, and you don't have to do that. And so if we have this, we could now go and just save this batch file. So I could just like save it here, and later on I can just like reload like all the batch steps from disk. I can also share it with my collaborators, and they can like work off from the batch that I created. And it's way easier to set up all the parameters and to add new steps to it. And so if someone failed to process their data set completely, you can like get back to this step and just do it again later. And it's just going to take like a few minutes, like maybe 5, maybe less. But for the downstream analysis, we're now going to export files, and I'm going to do it with the manual steps again. So align feature list gap filled. We select it, we go on feature list methods, and then in export feature list, we have multiple different formats that we support that link MZmine to other tools. The first one is the GMPS feature-based molecular networking formats. If you open this one, you only have to select a file name, a file path. It has to be a fully specified file path. So it's best to just click on select. And then here I'm just going to go workshop results and give it a name. So maybe GNPS FBMN is the feature-based molecular networking. And if I do this, I have specified the path. I can filter rows. This should be set to something with MS2. Peak area and simple. So those are the parameters that you can typically use to just create all the export files needed for GNPS feature-based molecular networking. Did you get there? Okay. Okay, so again, it's like featureless methods, export files, and GNPS feature-based molecular networking. And then I have to select again the file. And oh, no, it's a saved dialog. So you just give it a name. So you go into a folder where you want to produce all the output files. And then you just give it a name. I decided to give it GNPS FBMN because then I know it's for GNPS for the workflow feature-based molecular networking. And of course, you can say like DOM lab 15 FBMN.
For the sake of project organization, I would strongly recommend you to add like the lab number.
Yeah.
And once you like work with your own data, and if you do that a lot, I would also add like the date so that like matches the other records and some like descriptive like name for like that.
All right. GNPS FBMN app 15 DOM enter. .d. All right, so we can have a name like this. Just make sure that it's a real file path so that you don't, and I typically also do it on like a local drive. I don't like to push files like directly onto a server. It's just like personal preference. And just make sure you select MS2, peak area, and simple. And if you got that, we can click on OK. And it's going to export all the files that we need downstream. And I'm going to show you what kind of files these are. So, oh man, Windows 11.
For the MDF file, right?
Yeah. Oh my God. Open. What? Oh. So we might have missed something, and no one of the power users was getting that. So that was a test, and everyone in the room failed, especially me and Steffen. But that's a good way to test the batch mode. Because now we failed at something and we can directly reprocess in just minutes. So looking at the batch mode here, in the local minimum feature resolver step, there's one little checkbox that you have to check. This one. Yeah, so the batch mode, you can access from two ways. You can go on project batch mode, and you're there. And if you already have some batch files, you can just import those. Or from one of the process feature lists, you can right-click summary and then open in batch queue. Yeah, so you open, you replace, and then you have all the steps that you did in the batch. And we can see that someone forgot to pair the MS2 spectra with the actual features. So this parameter is very important because it sets up some ranges, some tolerances to attach the MS2 scans to the features. Yeah, so there might be multiple features in range, and so we have to just set up some tolerances here. So everyone, please get to the batch mode and make sure to open by double-clicking on local minimum feature resolver, opening those parameters. And so on the aligned gap field, I right-click, show feature list summary. So feature list summary, the second item. And then you can open in batch. And you get here. And from here, if you have some steps because you did them like multiple times, you could now clean it up and you could like remove them. But the most important part is to go for local minimum feature resolver, double click. And in here, we have to set up the MZmS scan pairing. So please check this box and click on setup. And so for this step, we have to click check this one and then set up the ranges. And those ranges, oh yeah, got to put them here. Then so those ranges are here. So there. So we set up, and those are the ranges. It's basically the full width, half maximum here for the feature. And we already saw that some features might have some tailing, or they might even have some fronting. And then the MS2 spectra might be triggered a bit later because during the main scans, there was already other things being triggered. Yeah, so we set it here like to something about the full width half maximum. And we also use a relatively wide MZ window. But if you consider that your quadrupole that is selecting the ions also has a pretty wide window, you're definitely gonna have signals in there in the MS2 spectrum if something with like 10 ppm was like detected at the same time, or like 0.01. So the quadrupole usually has like a unit resolution, a bit better if you have a good quadrupole in your instrument. Yeah. So make sure that you set up those two parameters, and all the other checkboxes don't matter for this workshop. Just give some more options, and then OK and OK. So all the other parameters stay the same. So it's OK. And then I would save the batch. So I go summer school 2. And now I want to reprocess all the files. Okay, and reprocessing all the files, you don't have to clean up before, but we can do it for now. So just so that you see what happens, I just click here and select everything by like Control A, or on Mac it's Command A, and then just right-click remove feature list. Yeah, so you can just select everything, Control A or Command A, and then right-click, remove feature lists. And then from the batch queue, if we see that we already imported the MZml files, so we don't have to redo this, right? So I would go and I would just kick out this topmost step because we already finished that. We don't have to redo. So I just click on this button here on the bottom. So select import MS and kick out. Then all the other steps we could just reapply. And this is going to matter. So we just say all raw data files. All raw data files. So the first 3 steps should have all raw data files selected here. Okay? Just make sure before you run the batch. All raw data files. Okay. So only the first 3. And why? Because mass detection and the chromatogram builder run on the raw data files. If you have the import data as the first step, we're gonna just pipe in those data files into the next step if you select those created by previous. But because we already have them, we just run with all raw data files for mass detection and chromatogram building. Local minimum feature resolver and every other step can be those created by previous, but this should be selected by default. So those should be selected by default. And I'm just going to click on OK. And everyone should do that now. And if they have some problems, we can fix it later. Oh, wait. Did I? Oh, my God. Why didn't I kick it out? I only told you to kick it out. All right. Okay. Okay. So all raw data files. Okay. So I hope you were better than I was. Yeah. 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 That's maybe. Yeah. I guess they're gonna say that afterwards. Yeah. Yeah. But then they have to download first, and right. So I hope everyone was able to do that, and we do have a backup. So if you didn't manage to get it to run like I did not manage to, you can download the in the Tuesdays folder. So for today, we have an XML file here, 2022 summer school, and it's actually the MZmine batch .xml. You can download this and then import in MZmine. And as I did before, so we go on project and batch mode, and then you can, as we saved, you can also load the batch mode. And if I do this, so like here, save first. So if I import a batch mode like this one, I usually just replace it. So it just replaces all the steps that we had before. And so if you didn't manage to do it just now, you can just download this batch file. Your collaborator was smart enough to share a file with you, and you can use that file and then just run all the steps in it.
Maybe to add like a couple of parts to that, because I think this is a really critical moment now for us to like also proceed with like all the other tools downstream. So that feature finding, I know it's complicated, but it's also very central, because if you like mess this up here, then like everything downstream might not go as expected. Right? So like I think here it's really important for the sake of like the learning experience of like the other modules that we get like good results out of it. Hence, I mean it's great. So like I think Robin and Stefan walked you through like each single step, and I hope that you kind of like now understand what's kind of like happening under the hood. But for like the sake of like proceeding now, I would actually go back to the batch Robin just highlighted, and then load this. And then the only thing you need to do is change the file path to actually take the files, because they're like obviously with like the different labs, you know, they're like they have different file names on your computer. And then also like specify like the file path for the output files. So all the rest of the settings are kind of like preset. I would give the mass detection thresholds perhaps like a little check, because even though this is all Orbitrap data within the data sets we selected, there might be like some tiny differences between like the different platforms.
And that's actually also what I already saw. Like some people were like, but wait a minute, it doesn't look like for your data set. And it's kind of like the task later on that it's like a similar platform. It's all run on Orbitrap instruments, some like lower end, higher end Orbitraps, and like the resolution is a bit different and so on. But those differences is actually what we want to test with the interlab study, right? We want to see like, do they have some problems with the sensitivity, retention time shift, the quality of MS2 data. So who's doing well? And it's interesting to just compare. Is it the same instrument really?
So yeah, if you have any doubts there, don't hesitate to ask. Right? So I think this is really important. Also, if you like start with metabolomics data analysis, especially like to the beginners, so be aware that this is frequent. Right? This can like screw up your entire downstream analysis. So I mean, it's kind of like we want to like equip you with like, in our opinion, like best tools. Right? But here feature finding is really an important step where you can do things easily wrong. So yeah, just to reiterate on that.
And if you think that you maybe missed some explanation or so, since we're streaming everything and also recording, you can, after the summer school, go back to the recordings and go through it again. So yeah, if you have any questions, you can also feel free to reach out to us. But yeah, since we already also have the recording, it's like some good resource for that.
Yeah.
So maybe like for like the remaining minutes, you can like load the batch again and then set like the critical settings. Yeah. And then you can all process it. I
also just updated the batch file. I gave it like a very nice final name, and I also kicked out some of the unneeded steps. So just make sure like download this little file. Is the XML file, and now it's named final MZmine batch, so that you actually know it's from MZmine and not just summer school. And oh my god, like this. And just to do like do it with you and follow along. I mean, like if you really run from the batch file, this is lab 15, but that's why you can run from different steps. So first, you just open the batch file. So we go on load, we select the final MZmine batch and open, replace. It's going to replace all the batch steps that you have previously. And now, for everyone who had some struggles and maybe MZmine crashed or did anything, I basically did like a clean startup. Everyone else who already has the data files can work from a different step. But so for everyone who wants to re-import the files from like a clean start, we select the files, all MZml files, and they are in my workshop folder. And you should see something like this, like all the files with your path in it. So I selected. get here, it's project and batch mode, or Control B or Apple B. Yeah. And then we load it with load and final. Yeah, like the one that I gave everyone. And we open and replace. And from here, like the most important thing always, this is what you do mostly in MZmine. You open a batch file and you modify a few parameters. So we double click on the import. We do all MZmel files and select the folder where they are located. And then you should see something like this. And then we press OK. And then all the other steps are now already set up. For series and so on. I did, just now.
Anybody having problems?
Yes or no?
In the Google Drive folder for Tuesday, you can find the batch file. Who said yes?
Should be in the shared slides Tuesday folder. Oh my God. Question explosion. Yeah. No, yeah. No, I gotta do it. Yeah. Okay. Okay. Oh, there. I know. Then you. I'm gonna Mit dem Batch ist normalerweise zeigt er das ja in den ja. Okay. Can I? So can I say one thing? Yeah? All right. So just because many people have the same problems, right? I'm just going to try to consort the conversation so that everyone maybe knows where problems are. So usually, like all this complex clicking that we did, we usually don't do. So we usually directly jump into the batch mode. And so did everyone manage to at least download the batch file from the Tuesdays folder and go on load and has kind of like this now? Someone disagrees? No. Okay. So and from here, the most important things that you always have to also tell your collaborators is change the input path, because my local file system is different. So I just double click on the import MS data. I think all MZML is the easiest if it's MZML. I only have to select the workshop folder. So I just go here, workshop and OK, and then it fills out like all the MZML files. Otherwise, you can also click on select files. Then you actually see the files. And of course, you can just like go down and select all of them manually here, right? But so as soon as you have all the files, you can click on OK. And then we have all those steps set up with the parameters that we used here which might not be optimal for your data set, but that might be something that we can discuss like in the next days. And if we now go further down, this computer. Yeah, so like this. So if we go further down, the only like important two steps that are now new here is the export for GMPS and export for series. And with the export for GMPS, you double click and you have to make sure that this is actually a file path. There's no files yet because we create those files, right? But so you go and select, and in here, I'm just gonna like give it a name. Just gonna give it a name, and I create a new folder to just have like all the output files in a clean folder for now, like results. So I go and save, and now we have here our file path. Those parameters are all set up because I already fixed them, and you don't have to worry about this. And then we have the export for series, and it's very similar. We just set up a path. So I double click on export series, I select a path, and of course I want to have like a similar name. So I just gonna name it not GMPS, feature-based molecular networking, but rather Sirius. Yeah, Sirius Lab 15 DOM interstudy. And with this, I don't have to set up much more, and I can click OK. And then on your side, I would go and save the batch again. So just click on save and override or create your local copy of the batch, basically. So you save and OK. So we have something to fall back onto. And then for me, I don't have my MS data imported, so I'm just going to click on OK and run through. So everyone who has no raw data imported can click OK now. Everyone else can wait for me to open it up again. So I do it, and it's going to import all the files. It is doing chromatogram building, resolving, and all the other steps, creating an aligned feature list, and then exporting for GMPS and for series. And it's already exporting the files. And I set it to open the folder afterwards so I can actually see the results. So we have now 3 files. One is named Sirius, and 2 other files are named GMPS. So you should end up with this. Of course, for everyone who already had the data files imported, you don't have to like do like a clean start. Again, we can go on batch mode. We open the batch mode. And from here, we can always, like remove the import MS step. And that's only for everyone who already has MS data imported and wants to redo the analysis. We just remove this step. And then we need to just set all raw data files for mass detection, for both mass detection steps, all raw data files, chromatogram building, all raw data files. You have to make sure that the file paths for the export are actually a file path to your drive. Yeah, that's the most important part. And then I can just rerun. And even though I did that just now, right? Maybe I changed one parameter, I want to rerun. I can just do that. And it's not gonna clash with the files that we already processed. It's just gonna redo it, and I'm gonna overwrite the series and GMPS export. And you can see at least the batch mode is actually pretty simple. You have everything like streamlined, and you get those files here. Yes. And that's why you should change the file name, of course, if you want to keep both. So yeah. Oh, it didn't.
No, but I stick with my data, and then make more people maybe do a file and then all the that's the exporting step.
Oh,
Can we just look at the parameters?
yeah. Yeah, totally. I also shared in the Tuesdays folder. There's also like some slides. So everyone who was kind of confused by this presentation can like go back to the slides also, and there should be like down here. You should have export submit to GMPS is the name in the batch mode. And then you have like export feature list and this, and there's the parameters. And also for series, the parameters here. But also in MZmine, I can open it up. And it's also quite easy if you don't like already have the step in there. I can just type in series in the search box and hit enter. And then it directly gives me the parameters, and I can click on OK, and I'll have a second export here. Yeah, so if you want to build the batch like one by one, you can just go through the tree, or you can just say, okay, I want to have feature-based molecular networking. All right, search for a filter, and then add the step to the batch. Okay. Yes.
Crashing a lot. So batch queue, like how to incorporate some of the data, like try to process some points, some data, and then just do the feature alignment and everything on all data at the end.
So yeah, so I mean, some people might have some problems with the steps, like if some parameters, because it was very fast, right? And there's so many parameters to set up, so maybe you also got some parameters wrong, and then you get like way too many features, and it's like way of too big of a problem. So then you can start like fresh from my batch, but also some of the data sets might have higher noise levels, and we didn't really optimize for every data set now. But that's also going to be like one result, that maybe the lab, like the instrument that they use, has like a higher noise level, or there's some other contaminants in the data, so it might be like more complex or something. But you can always like sit together with like your group, and maybe we can ask from the group, maybe we can ask that every group at least gets like one data set that ran with those parameters, and just get the files, because you only need like 3 files that we're going to work on with down the line, and they don't have to come from your laptop. So yeah. If you can delete the raw files when? Or okay. I mean, you typically want to keep the raw data in MZmine. If you look at memory consumption by Java apps in like the task manager, it doesn't really tell you the truth. So it might say like MZmine is taking up 90% of your memory, but it's actually not doing that. It's lazily giving it back to the OS if the OS demands to have more memory. At least for MZmine, you can see it like on the bottom here. It says that there's like 5 GB free from 16 that it currently uses. If I click on it, it actually frees up memory, and it's actually 15 gigabytes, like nearly 15 gigabytes free. So it's like very lazy in giving back memory if there's no one asking for it. So usually the memory footprint is way lower than what you see in like the task manager and so on. And like should be. But we can look at it if you have some problems afterwards. Okay. So everyone should have those files now, right? Yeah. So let's see. Just to show you what kind of files we now produced. I'm just opening the MGF in just any text editor. The data exchange format here is just text-based, so it's very easy to parse and also to understand by humans. And the MGF is a format that is for spectral information. And for GNPS, we use MS2 spectral information only. So each of the features that we picked that has an MS2 spectrum is now exported once in the feature list, and then also as one MS2 spectrum here. So you're going to see begin ions, and then it ends somewhere here. One spectrum ends and another one starts. And we can see the precursor MZ and so on. And the second file is here. And I'm also going to open it in just any text editor. And the second file is actually just CSV, so comma separated values with all the features that we saw in MZmine. So we have the row ID, MZ, retention time, and then we have the matrix of the feature areas in all the samples. And that's it. And those two files we're going to send to GNPS for feature-based molecular networking.